A charge Q is distributed over the surface of two concentric hollow spheres of radii R and R, that is greater than the previous one, radii, such that their surface charge density are equal. Derive the expression for the potential at the common center. Okay. Now, we are supposed to know here the first charge. Charge is equal to, that is Q is given by Q1 plus Q2, which is nothing but 4 pi sigma times R square plus R square. Okay. And the potential at the common center, that is V, is given by 1 upon 4 pi epsilon naught times Q1 by R plus Q2 by R. If you are going to substitute this Q1 and Q2 value, you will get 1 upon 4 pi epsilon naught times, that is 4 pi R square sigma by R plus 4 pi R square sigma by R, and we will get here R plus R sigma, that is equal to epsilon. Then we know that if you take the common 4 pi R square sigma, R square plus R square is equal to, that is the capital charge Q, then I can write it as 1 upon 4 pi epsilon naught times Q times, if I take the LCM where it becomes R plus R divided by R square plus R square. This is the expression for the potential at the common center. Three concentric metallic shells A, B and C of radii A, B and C, A is less than B, B is less than C, have surface charge densities plus sigma, minus sigma and plus sigma respectively as shown. First, obtain the expression for the potential of three shells A, B and C. Okay. So first we need to find the potential difference of all the three shells, that is VA is equal to KQA divided by A plus KQB divided by B plus KQC divided by C, and VA is equal to 1 upon 4 pi epsilon naught times 4 pi A square sigma divided by A, and next one is a minus sign because they are given, that is the negative sigma, so it becomes minus 4 pi B square sigma by B. Next is positive 4 pi C square sigma by C. Then we can write this one as sigma divided by epsilon naught times A minus B plus C. This is at VA. Similarly at VB, this becomes KQA divided by B plus KQB divided by B plus KQC divided by C. Then substituting the values, VB is equal to 1 upon 4 pi epsilon naught times 4 pi A square sigma by B minus 4 pi B square sigma by B plus 4 pi C square sigma by C. We get the value VB is equal to sigma times epsilon naught into A square minus B square divided by B plus C. Similarly, at VC is equal to K Q A divided by C plus K Q B divided by C plus K Q C divided by C. Then which is equal to 1 upon 4 pi epsilon naught times 4 pi A square sigma by C minus 4 pi B square sigma by C plus 4 pi C square sigma by C. And the final equation, that is VC is equal to sigma times epsilon naught of A square minus B square plus C square divided by C. These are the expression for the shells A, B, C. VA, VB and VC values. Part B. If shells A and C are at the same potential, obtain the relation between A, B and C. Okay, that is VA is equal to VC. Then it is the values are A minus B plus C is equal to A square minus B square by C plus C. Then we get the value C is equal to A plus B. This is the relation between A, B and C.